Welcome to Special Topics in Supply Chain Analytics. In this first session, I'm going to walk you through getting up and running in Python, specifically through the Anaconda Navigator, and alternatively, directly through Jupyter Notebooks. And the brief discussion will involve moving averages. Okay? All right, so a couple things. After getting Anaconda installed, if we open that up, the important thing to understand with using Jupyter Notebooks is it's a cloud-based IDE, and IDE stands for Integrated Development Environment. So being cloud-based and web-based, it's great for prototyping. As discussed in our class session, there are other IDEs that would be more optimal for intensive usage of resources on a computer. Spider being one, PyCharm, and these are local. We've also discussed RStudio, but that'd be more for the R programming language, not per se. So if we're going to integrate in using Anaconda and accessing R, this is kind of a platform we could do that through. Once Python is installed and you've installed Jupyter, okay, so it's no longer installed but a launch, clicking on simple launch will open up the web-based version, okay, and at this point we need to locate where the notebook is, okay. So by default it's going to go to the hard drive, and I would recommend I have these stored on the desktop and Supply Chain Analytics, and here's the notebook. Okay, essentially this contains our script and objects should we have them any loaded. So within a notebook, and simple clicking to open will populate that. The nice thing about Jupyter Notebooks is it gives you the markdown feature. And what I mean by markdown is for annotating purposes. Okay, so if, for instance, creating some hyperlinks like so, for this particular session, we can define and kind of move back and forth and write notes and also run our code. So that's kind of a nice thing for purposes of this session in this class, is using that. And then the alternative, we didn't want to open up Anaconda Navigator. We simply could have opened up this other way. Jupyter, and what we would see running in the background is code like so. This would be running in the background. Whatever you do, you don't want to close this out whenever you're seeing this run independent. It opened up another tab for us to open a file. And as shared before, you want to designate, I've got R already integrated in to kind of go back and forth. Most likely yours would be just Python 3. Okay. So now that we have the notebook open, going through and understanding what's going on, right? So this is our notebook, and there's a couple of things that we need to do so that we access features within Python. As shared with you, when we open up software kind of like Excel or SPSS, we get the whole buffet all at once. So we get all features, and that's nice and all. However, it uses more resources. So for efficiency, programs like R, Python, we install packages or libraries and use them as needed. There's an install, and then we import and we call them. And that's what's going on here. So NumPy and SkyPy, okay, and Pandas. And then, as shared with you previously, when we do the as NP or as PD, that's basically abbreviating it. Otherwise, anytime we use this function, we would have to always call it by NP or NumPy or SkyPy. And instead of the NP down here, like on this building out a function, we would have to say NumPy append or NumPy.append. So by this, it's more for cleaner coding, right? And so that's what's going on when we're importing libraries. As a refresher, how do we run code? You can either click your run this cell button here. You can click in the cell, click run. If we don't have a cell designated, and we run, it'll run all the code. We've got a cell designated. You can do click in a cell and hit Control Enter, and it will only run this cell. Or if you click in a cell and hit Shift Enter, it will run the cell and give you another blank cell at the end. So there's a couple options there. As a reminder, to add a cell manually, we use the escape key. So to add a cell below would be escape B. Okay. To remove it is escape DD. To add a cell above this is escape A, right? And to delete it again is escape DD. You can find these functions and these shortcuts right up here. And it's an assumption with using the escape key. So that's where it's a little bit unique, particular to Jupyter. So, and these are the shortcut keys that I was using. All right. So in the first part of this chapter, the notion of moving averages is brought up. And it's relatively a simple concept, but it's a very important concept because we're talking about a series of data and in a very, using it loosely, elementary form, how do we take a series and determine how much to forecast in the future for time periods and what type of intervals to use to make projections, okay? And so we're going to create a function called moving averages, and this is in your textbook. And the syntax is important, but a little bit beyond the purposes of the class, and we can walk through it. Nan means a missing value. So the way that this function is going to work is it's going to calculate based on parameters that we set right here. So this is calling the data frame D for, and it's more of a placeholder. Our extra periods, we're setting that. Okay, so do we want to calculate 2, 3, if we can, additional projections, and the n is the interval ratio. So are we going to calculate our moving average based on 2 previous time periods, right? So that's what's going on here. So if we run this, we now have this function that's been initially started. And we can see that by this 1, right? So this is telling us that it ran. We don't really see the feedback per se if we were to call like an object. And that's an important thing to bring up too. When we talk about Python and R and these types of languages, they're object oriented. So we're storing arrays or list into a variable. Okay, so moving along, we have an example in the textbook for a moving average, and I took it a little bit further and stored it as an array because list, we can't do calculations on those values. However, we can on an array. And so for purposes of teaching you, we want to store values that will perform calculations and metrics on as an array. And a couple of points of interest here. So here's a couple of important things to understand when we start talking about lists and array. Behind the scenes on a computer, we're using the NumPy library, i.e. package, and it requires less memories versus a list. Okay, faster and to some degree it's a little bit more convenient. So that's why we're doing that. Kind of breaking this apart a little bit more. We're going to call the object D, and within D our array is stored. Okay, and there's a couple things that I'll show you whenever we want to view what's in this array. Sometimes we can see an output and sometimes we can't. Okay. Okay, so it's already stored here. So let's run it. Go back up here. And here we go. And right now, so by us calling and printing the data frame, we're not seeing any type of output. However, if we were just to call the variable by itself, the df, and rerun our cell, you're going to see an output showing this. Okay, it's still in a data frame, and we know that because on the left side this is an index. So when we see this 0 through 20, that's the index line. It's very important to understand when looking at data frames, on the leftmost column, this is our reference, and the point value of 1 actually begins at 0 versus 1. So it's a little bit unique, and make sure you understand that. Argument one would say, well, in there 21 values? Yes, there are, but we begin at 0, and that's kind of a programming thing. Okay, so we have our values. They're stored there. We can see that output. We can do the print df, or just call the data frame by itself, and that's what df stands for. So now we've got our data frame. We want to test out this moving average function that we've created, and the way that we do that is we don't really use spaces in Python. We use either underscores or periods if we want to extend out our variable. And so I took the df and put a period MA just to denote it's a moving average. Okay. Again, we're going to calculate one extra period. This is our original function. It's defaulting towards, right? So if we were to put something in, and this is our interval. Let's go 1. And if we project it out, we can see we're using one value, which, let's go 2. So we're going to use these two values to project and forecast time period 3, but index as 2. And we're going to project an extra one. So that's why we have a value here. Remember, the NaN means there's no value. So we don't really have, per se, a demand number, but this is the average, okay, of 10 and 12 to project here. Another important thing to understand that was written within the function is the error. And we closed off this session. This is something we're going to look at throughout this course, is differential, and the differential of what we projected versus what was forecasted. And so error, bias, those types of things are really, really important when we understand our modeling for forecasting. Okay. Moving on, how do we visualize this? So this is nice to look at, but how would we visualize this? And this is where we use the Panda library. And we've already named it .pd, okay? And within that, let's go back up here so you can see. There are the map plot notes, what we're going to call that one as well, to kind of create these graphs. Important to know, whenever we populate a graph, we see only the value points, and so to call on the label, and the X and Y, so the chart title and the X and Y labels, and to some extent the limits, we may have to override those or integrate them. And so if we want to visualize it, I'll just use a shortcut, Control Enter, and it's plotting. So it's the first one, our second one, and what's going on here, pardon me, we're calling the data frame that we've populated. So this is our object. So here's the moving average. All this information is stored in data frame moving average, or daf.ma. And so whenever we take this and put it with this type of syntax and dot plot, it says we're wanting the system to evaluate, it looks like a time series, and plot it out. Okay. We could flip it if we wanted to make the X and Y axis. It's a little bit beyond our session now, but just know behind the scenes, it's looking at the series increase and populating it, right? So based on their index working as the x-axis and the variables that we've integrated and then calculated as the y-axis. Excuse me, yes. Okay, so here's our x and here's our y-axis intersections. So to customize the plot, because what does this have to do with? How do we add a label or chart title to it? What if we want to adjust the limits on the y-axis or the x-axis? We can do that. And maybe we want to make our lines look different. And that's what's going on here. And this particular code will do that, right? If it was not here, I'll leave it. We can copy and paste this in, it'll drop it in. Okay, so let's run. And we can see here, just for illustrative purposes, let me do this. Let's do extra periods 3. Call it. And we're going to see 3 no values or null values. And when we run this chart, we're going to see it flatline. And what that means is we're not getting any new projections. Okay. We can see that here. You say, well, Keeler, that looks a little bit different. It does, because for one, our X limbs are adjusted. Right here, it's kind of defaulting to what the computer thinks would be best. Starting at this value here, here is overridden. So we set the Y limit to 30. So it can kind of make it a little bit tighter if we want. Building on, so this particular code here, title equals moving average. Simply added this, and what else happened with this particular code as we added on to it. If we change the plot size, we can make it a little bit bigger. So let's make that a 10. So this is length and width. So if we make it a 10 by 3, we just made it longer. We'll make it bigger. Okay, so there's a way to kind of manipulate the figure size per se. And we've talked about style. Okay. What if we would like to say, well, what scale is the x-axis on and the y-axis? How do we adjust that? And it's AX stands for axis, so axis set. And it's important because with this particular object, we're calling it and we're cross-referencing it to these axes, right? So in this instance, here's our period and quantity. We've set the labels. If we were to create another chart for your practice like we do, we need to change the label of this. Otherwise, it's going to try to cross-reference back here, and it'll kind of make the computer a little bit confused. And you're saying, well, it didn't change the, you adjusted the size up here. Why didn't it adjust it down here? Because I essentially overrode the size back to an 8 by 3. Okay. Important to understand, this image here is not stored into an object. This image here is stored into an object called AX. And now here we set the axes. So set X, or excuse me, our axes would be the limit in our labels, right? So we're setting the labels on this object. I put the code in here just more for illustrative purposes. We've already kind of looked at it, right, when we call it. Moving along, as we closed out our session, as you all worked through this, I said, well, we're getting into key performance indicators, and this is an additional function that is written out in your textbook, but I told you throughout the rest of this class, we're going to be looking at things like bias and mean absolute percentage error that helps us to differentiate what's the best model and algorithm to do forecasting. Okay. So it's more of a prelude of what's to come, but we'll use these metrics throughout. And I'll talk more about this in our upcoming session. For your practice, this is in chapter 2, there is some data, and I ask you to have your hand in it, right? And so I changed the object name to CP simply for class practice. Okay, so if we were to take this, Control C, drop it in here, and hit run, we now have an object, and we can check it. So here's our array that's stored. And let's take it a step further, and let's calculate our moving average. And again, I'm just using, kind of doesn't like this, so we have to re-trigger it. My apologies. I'm cross-referencing the wrong. Let's go here. Okay, and so let's calculate the new object with the moving average. And here's something to look at as code. Remember these fields that we established early in the function, they need to point to the right direction. These are essentially toggle switches. However, this right here is extremely important because this is our data frame. DE is not the data frame that we are using now. Okay, because since I changed this to this object name from DE, it's now CP for more of a class practice object name. We need to change that to CP. So this is where it's going to pull the data when it runs this macro, right? So as a student said in our session. So yeah, functions are essentially like a macro. And so we'll calculate extra periods, and then we're going to use an interval. Let's make it 3. Run. On the initial, it doesn't like it. Let's go 2. There we go. For whatever reason, on the initial run, the system doesn't like that. We can come back and make it a 3 now. It's just the initial run, right? So now it works, right? So know that we don't. If you get an error, it's important to realize that it's like, well, is it broke? No, for whatever reason, it's a system thing. So run it once, drop it back a level, and then you can go really anything you want. All right. So we have our values. And this is a little bit different, right? Because not per se the index values, but our Y values, our Y demand values and our forecast values are a lot different than the original of 0 to 30. So if you calculate this and use the other, let's do it. If you copy and pasted the code, and if you have an XLim value of 0 to 30, you're not going to see a whole lot because it is below the limit. So you need to come back up here and change this. essentially you could leave it out and it'll try to find the best fit for that. And so now we can see that value, and it looks like it's tapping out up here at 198. So we may want to go to 210. And kind of similar to what we've already done, using our dash and double dash to kind of differentiate our lines. Okay, so as we get ready to finish this up, as mentioned, we're not per se pointing this chart here to an object. We're essentially calling the object and say apply these parameters. But in this next step, we're going to apply it to an object. Okay, and we need to make sure, since I changed up, this is some older code, but I changed this to more of the class practice, this dot extension. It doesn't really, it's not like a, it's just nomenclature, right? So how do we keep extending out the name? So that to me, this is data frame MA, and this is the class practice data array. All right, so, and I only point that out because we got to change this down here, and more for cleaning up the code to see it a little bit easier. Let's do this. Makes it easier to see. So we need to change this to CP. And what we got going on here. So we're calling this object, which is back up here. We're calling that object, and we're going to point it to a new object. We're still going to plot our demand and our forecast. The plot size, we could change that here in a little bit. Our title, our limits, our style, that's the same. But here the additional component is we're going to add X and Y labels. Okay, so just do Control Enter and run, and there we go. And to 10, looks like our values are starting around 37, so we could bump that to 30 if we wanted. It kind of tightens it in a little bit. So in this session, covered getting Python up and running to some extent, but really integrating in a function, how we use a function. We did not do an import of an Excel file. We will eventually. We just built these from essentially scratch in an array form, but converted them to a data frame, which is important, right? So know that we cannot do any type of calculations on lists, but it's really on arrays. And demonstrated how to adjust our projection of how many additional points in time we want to calculate our average, and then on that time series, how many months or years we would like to use if that's 2, 3, 4, 5 in the interval. As I shared with you in class session, in my prior career of doing lending, we called it a trailing 12 months. So we would use the trailing 12 months to project out the next month of revenue. And why do we do that? We use moving averages to help smooth out seasonality and oscillations that may occur in points of time. Okay, and so it's a way to smooth out and to remove a little bit of the variability. As we go through chapters 2, 3, and more in this session, we'll see how exponential smoothing can kind of work, and it may be better served, but it kind of gets back into those key performance indicators in chapter 2 that we'll talk about, right? So as we look at bias and mean absolute percentage error and RMSE, those types of things, well, give us indications of what might be a better method to project out and forecast demand. Okay, well, that's all I've got. So thank you.